a.m. my time, so it's time to get started. I want to wish you all a happy Friday and a thank you for joining me on this Friday morning. And today we're going to be talking about the Zigbee wireless protocol and its factory applications. So I will be specifically featuring an automated guided vehicle application from our home office in Taiwan. So let's take a look at our agenda for today. First, we'll get an overview of the Zigbee protocol, how it works, and the advantages it has compared to other wireless protocols. Then we'll dive in and talk about the automated guided vehicle system. And then we'll get into the specs and selection for our Zigbee products before diving into the Q&A session. I have our application engineer, Robert, with me today, and he's going to answer any of your more technical questions. I do ask that you hold your questions until the end of the program, but if you think of something along the way, feel free to type it into the Q&A box in your Zoom toolbar, and we'll get to those on a first-come, first-served basis. For the rest of you, you can type or ask your questions during the Q&A session. Or you can ask your question on mic if you have a microphone. And just do that by raising your hand through the Zoom interface and we'll get to you. So first, a little bit about us, if this is your first time joining us. ICP DAS was founded in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA was founded in 2001 to support the North and South American markets. We are located in Lomita, California. We have over 100 R&D engineers working to develop new products and to support our customers, and we always take customer input very seriously when it comes to designing new products and updating our current products. We are ISO 9001 certified in the States, SGS certified in the UK, and we are a Windows embedded partner, and our products are RoHS compliant. Let's talk a little bit about the Zigbee protocol. Zigbee is a wireless technology developed as an open standard for low-cost, low-power wireless IoT networks. The Zigbee standard operates on the IEEE 802.15.4 physical radio specification and operates in unlicensed bands, including 2.4 GHz, 900 MHz, and 868 MHz. Zigbee is managed by the Zigbee Alliance, again, as an open protocol. The Zigbee Alliance is a consortium of over 300 technology companies that develop and manage the protocol. Some of Zigbee's features and advantages. Zigbee is designed to communicate data through the kinds of noisy RF environments that are common in commercial and industrial applications. It does this by using a different bandwidth than Wi-Fi. And furthermore, connecting Zigbee networks to the IP domain or cloud server opens up monitoring and control from devices such as smartphones and tablets on a local area network or a wide area network, including the internet. So some of the features of the Zigbee protocol is its support for multiple network topologies such as point-to-point, point-to-multipoint, and mesh networks. The mesh topology is probably what Zigbee is most known for, and we will be looking into the applications of a mesh network for factory automation in just a second. Excuse me. Another key advantage of Zigbee is the low duty cycle, which provides a very long battery life. It's also low latency, and it does provide 128-bit encryption for a secure data connection. So let's talk a little bit about the mesh network. A key component of the Zigbee protocol is its support of mesh networking. In a Zigbee mesh, there are coordinators and routers. The coordinator is the access point, and the routers are often the end devices. But each of these routers is interconnected with the other routers so that multiple pathways connect each one. Connections between each device on the network are dynamically updated and optimized through a mesh routing table. Mesh networks are decentralized in nature. Each device is capable of self-discovery on the network. As routers leave the network, the mesh topology reconfigures routing paths based on the new network structure. The advantage of a mesh topology in ad hoc routing is it provides greater stability during changing conditions and during the failure of a single node or a single router on the network. So let's dive in. I'm very excited to talk about this application today. And this is a smart factory automation application designing a route management system for automated guided vehicles. So in the past decade, unmanned factory and warehouse automation systems have gone from science fiction to reality. In warehouses around the world, automatic guided vehicles, or AGVs, are used to transport goods to and from product lines, storage systems, and transfer stations. But when you have a warehouse or a factory full of automated vehicles, their driving routes will quickly start to overlap. Consequently, preventing route conflict is the key issue in this kind of factory automation. So, ICP DAS USA has designed an application to solve for the routing and management of multiple automated vehicles on a crowded warehouse floor. The problem with automated vehicles is regulating traffic when multiple AGVs have access to the same lane, creating congested or dangerous areas. With a network of Zigbee wireless equipment, we have come up with an elegant solution to managing access to these busy lanes. When an AGV is about to enter a restricted area, such as the main road, track, or elevator, the AGV needs to send a request to the Vehicle Management Center to gain permission to enter. Once the center approves the request, no other AGV will be able to enter that area until the original AGV departs and the management center releases control. Other AGVs can then apply to enter the restricted area. So each vehicle sends messages to the Vehicle Management Center for permission to enter, and then sends an area disabled message to all other AGVs in the region. The Vehicle Management Center can be seen as a type of virtual cloud with an M2M architecture. Since the AGVs are mobile devices, we can take advantage of a Zigbee mesh network to keep the M2M communication system going with many vehicles moving in and out of the area. Each vehicle contains paired Zigbee I/O modules that communicate with the other I/O modules on the other AGVs on the network. The M2M communication is handled by our ZT-IOG Zigbee I/O modules. These are multi-to-multi pair connected I/O modules. The multi-to-multi I/O pairing ensures that any ZT-IOG module connected to the Zigbee network can be used to change the I/O channel state of all the other ZT-IOG modules. By changing the on-off state of an I/O channel on one vehicle, all the other paired vehicles will receive the message through the Zigbee coordinator, thus achieving a straightforward, fail-safe M2M communication. So the way message exchanging works, if an AGV is about to enter a restricted area, it first queries the Vehicle Management Center to see if the area is occupied, and then updates that status by changing the on-off state of the specified I/O channel on the ZT-IOG module. In this situation, the on-off state from one of the ZT-IOG module's I/O channels can be used to simulate an occupied or idle status message. And then the pair connection notifies the other AGVs in the area by changing the on-off state on the corresponding I/O channel on all other vehicles. There are two levels of control architecture with the AGV route management system. The highest level is the control level. The AGV is equipped with a PLC, PAC, or IPC controller, or similar industrial controller, And in addition to controlling the movement of the goods and the vehicle motion, this controller also manages the message exchanges among the vehicles in order to determine the status of the current route and calculate the required timing for any vehicles about to enter the restricted area. The controller will also communicate with the Vehicle Management Center, which is the master control system for all automated vehicles, which manages vehicle entry and exit and traffic flow. The second level is the message exchange level. So in addition to the Vehicle Management Center, the ZT-IOG network of multi-to-multi I/O pair modules functions as an M2M exchange medium. So under actual operation, if an AGV wants to enter the restricted area, its PLC or other controller will output a high state at the control level to trigger the DI on the ZT-IOG module. That's digital input on the ZT-IOG module. Meanwhile, the digital output for the other ZT-IOG modules that corresponds to that digital input will change to high based on the level mode updating logic, and will then trigger the digital input on the PLC for all vehicles and set it to high. This means that the usage status will be set to occupied so that other vehicles cannot enter this area. Once this AGV has left the restricted area, its PLC will cancel the high level state on the ZT-IOG modules, which means that the other AGVs can send a request to enter the area. So when you consider the application and architecture we've described so far, in addition to using the physical I/O on the ZT-IOG modules to simulate the occupied and idle status via the on-off state of those I/O channels, you can also use the serial port communication on the PLC to achieve the same message exchange function. So instead of using one of our ZT-IOG paired modules, you could use a ZT-2570 module. The ZT-2571 provides 280 pairs of virtual digital I/O channels that can access the virtual I/O channels via the Modbus RTU protocol. And the virtual I/O channel states can still operate in pair connection mode with the physical I/O channel states. And the DI/DO on the module with the virtual channels works in the same way. Okay, and that brings us to the end of our application example, and now I want to talk a little bit about all the different modules that I've talked about so far, the ones that go into making the application work. So I've talked about our ZT-IOG modules, and specifically, these are the ZT-2000 series IOG, referred to as ZT-IOG. So these are a series of Zigbee wireless communication modules with digital input and digital output channels. The IOG in the ZT-IOG is an abbreviation for the I/O group, and that means the multi-to-multi pair connection I/O modules. The ZT-2043 IOG is one in these series, and that provides 14 digital output channels. And users can easily configure it as either a Zigbee coordinator or a Zigbee router via the external switches. The Zigbee coordinator will serve as a message processing and distribution center, and again, any of these can be configured as the coordinator. So the Zigbee coordinator will serve as a message processing and distribution center. In other words, as long as any digital input of any ZT-IOG module changes its channel state, it will immediately trigger an event and upload it to the Zigbee coordinator for I/O updating logic calculations to determine the DO output states of the ZT-IOG system. Then, the Zigbee coordinator will broadcast a message periodically to all ZT-IOG Zigbee router modules to synchronize the DO channel states, and that's how you achieve the multi-to-multi I/O pair connection. So, in the alternate architecture slide, I talked about the ZT-2570 and 2571. So these are a series of small-sized Zigbee gateways. Excuse me. So the 2570 is the Zigbee coordinator, and the 2571 is the Zigbee router. These provide an interface between RS-232, RS-485, and Ethernet, and the Zigbee network. The typical transmission of ICP DAS USA ZT Series products is 700 meters line of sight, with a transmission frequency range between 2.405 GHz and 2.48 GHz, separated into 5 MHz sectors, providing 16 channels. The ZT-2000 series is not only a long-distance wireless converter, but can also act as a Zigbee router to extend the transmission range and improve the quality of the wireless signal. So again, the 2570 acts as your wireless access point and as the coordinator for the Zigbee network. You can use the ZT-2571 to connect RS-232, RS-485, and Ethernet devices to your wireless Zigbee network. And as I mentioned, in the alternate architecture slide for the AGV application, it provides virtual I/O channels that you can use to achieve a similar effect to the I/O pairing on the ZT-IOG modules. Now I think would be a good point to talk about a different kind of architecture. The application we're focusing on today, one that I like to talk about, the AGV example, is a very creative use for a Zigbee network. And as long as I'm talking about some of our other Zigbee products, it would be good to show an example of a standard network using Zigbee modules in a factory. So here you can see the ZT-2550 module acting as a serial gateway between what looks like one of our rack-mounted programmable automation controllers. And that acts as a serial gateway and a Zigbee host coordinator on the network. So the ZT-2000 I/O modules are connected directly to the coordinator, and down the line we have another ZT-2551 gateway connecting the RS-485 modules to the wireless network. But even further down the line, you can see the advantages of a mesh network, where you have even more ZT-2000 I/O modules connecting to the mesh through the ZT-2551, and then they're connecting back to the ZT-2550, which puts you in touch with our controller there at the very start of the line. So I'm hoping this gives you an idea of a standard Zigbee network architecture and the types of products we have, because we do have plenty of standalone DAQ modules that work just like any other wireless data acquisition module, which in addition to the I/O pairing modules. And just a quick overview of our Zigbee converters. I've already talked about the 2570 and 2571 at length. Those are the serial and Ethernet converters. And the 2550 are serial converters. You can see they have the RS-232 and RS-485 interface. We also have a USB to Zigbee converter. And here's a product that I have not mentioned, but it is a very popular one, so I think it's still apropos to talk about it, our ZT-CHK wireless sniffer. So this is a module that captures and analyzes over-the-air data packets, Zigbee data packets in real time, with its TI Smart RF Protocol packet sniffer. It's easy to install the ZT-CHK to your PC through the USB interface, and with the SPPS software, users can view or store the wireless data packets on the PC and, see what's in the data packets. This can be a good way for users to analyze Zigbee data in their applications and reduce wireless communication test time. And I did mention our ZT-2000 series I/O modules. Again, these are just like any data acquisition module. They provide I/O channels and they connect to your Zigbee network, which you then can connect to your control system. So we have the thermistor input module as well as standard analog and current input, and several different types of analog and digital output. Here we go. And here we have our digital input and output Zigbee I/O modules. All right, so now that I think I've given you an overview of what the Zigbee protocol is like, what its advantages are, and how it can be used, then we went into our AGV application and closing it off with some product specs and product selection. That about brings us to the end. So Zigbee is a new protocol, especially when you consider that industrial protocols developed in the 60s and 70s are still in wide use today. But I hope that the advantages of Zigbee are clear to you now. Zigbee's architecture allows for flexible, durable networks of devices to be built quickly and added to without the need for extensive foresight and planning. It operates on a variety of frequencies, making it easier to prevent electrical noise in an industrial setting. And Zigbee nodes consume very little power, making this a great solution for remote and battery-operated devices. And I hope that the AGV application provides an example of the full advantages of a Zigbee mesh network for the latest smart factory technology. With the Zigbee network and our ZT-IOG modules, we were able to develop a sophisticated traffic control and M2M messaging system using familiar components and little human intervention. All in all, Zigbee networks provide some exciting opportunities for automation while providing a flexible, energy-efficient, low-latency network. As always, why should you choose ICP DAS USA? ICP DAS USA has been a provider of industrial automation and data acquisition systems for over 20 years. We have longtime happy customers all over the Western Hemisphere, and we specialize in providing products that are reliable and affordable, the perfect components to round out your DA key or control system, improve efficiency, and connect legacy equipment with newer technology. So with all that said, it's time to move into our Q&A session. So if you've put a question into the Q&A box, we'll get to those now. But if you want to get on mic to ask your question, just raise your hand through the Zoom toolbar and we'll get to you. Like I said, I have my colleague Robert here. He's an application engineer with us at ICP DAS USA, and he can answer any of your more technical questions. So let's just see if we have any questions in